Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to continue from where we left off. We are on permutation and combination. In our previous lesson, we looked at how to simplify complex questions involving permutation and combination. Then we also looked at what equations involving permutation and combination and how to solve them. But in today's meeting, we are going to strictly look at permutations. Okay, which questions will usually be find the number of ways, in how many ways, okay, that certain arrangements could be made. Okay, so please stick and stay with me, and you know the number one rule, don't hesitate to ask any questions where, okay, the need be, or if need be. Okay, so now quickly, let's look at what the first permutation concept that we are going to look at. So our usual one, we know that we are going to look at the number of ways of arranging n distinct objects, taking R at a time. And please take note before I continue. Okay, for permutations, we have linear permutations and circular permutation. So unless otherwise stated, okay, any arrangement that we are looking at, look at it in terms of the linear sense. If it is circular, the question, okay, will guide you either directly or indirectly, you will be told. Okay, so in this situation, we are going to look at the linear, okay, like I said, aspects. Okay, so quickly, let's look at the number of ways of arranging n distinct objects taking R at a time. And we know that is denoted by this from our basic concept of permutation. So the number of ways will be given by n permutation R. And remember, I told you when I introduced you to permutation and combination, I told you that anytime you see arrangement, you see arranging, okay, or arrange, we are talking of what? Permutation. So that is a key word that we have seen here. And n distinct objects. Distinct, obviously, you know, we are dealing with different objects. Okay, so let's look at an illustrative example. And you know, by definition, n permutation R is equal to n factorial over n minus R factorial. Okay, by definition. So let's look at an illustrative example. In how many ways can the letters S, E, A, B arranged, taking two at a time? Taking two at a time. First of all, let's check. Okay, the letters that we have here, which are our objects, are they distinct? Are they distinct? Are they different letters?
Yes, please.
Okay, they are distinct. Okay, very well. And we are looking at arrange. Okay, so we are supposed to arrange this, taking two at a time. So we know if you count your n will be the number of objects. So 1, 2, 3, our distinct objects here, we have 3. So that's why it's a solution we have given C. And C, the number of ways will be, because we said n will be what? 1, 2, 3. And R will be, we are taking 2. So R will be equal to 2. So in this case, we are looking for the number of ways will be equal to 3 permutation 2. And we all know how to simplify this using a definition. So the definition of this one is 3 factorial over 3 minus 2 factorial. And you can see that I am writing more than 2 or 1 equal to sign on the same line. Okay, because this is an illustrative example. When you come to the actual ones, okay, I've told you avoid doing that. So this will be equal to 3 factorial over 1 factorial. 3 factorial we all know is 6. Okay, over 1 factorial we know is what? Is 1. So this will give us, so we have 6 ways of arranging, okay, the letters that we have here, SEA, taking 2 at a time. Is my point well made?
Yes, please.
So with this formula, okay, this formula will only tell you the number of ways, okay, but it will not tell you the individual arrangements contained in the number of ways. That's the difference. Okay, we know some of us, if you don't know this formula, okay, because we are taking 2 at a time, someone can write SE as one arrangement, okay, SA as another arrangement. We can have, you know, SE will also give us a corresponding arrangement, ES, SA will give us another corresponding arrangement, which would be what? AS. Remember the other matters in permutation. So the other one will be EA. Okay, and EA will also give us another arrangement, AE. Is that clear? So in all, if you don't know this formula, we know that how many arrangements can we get? 1, 2, 3, 1, 2, 3, so 6. So if you do this, you will know what is involved in the arrangement, okay, which you will use in getting your count, which will give us 6. But for what we have done here, it will only give us our count, our number of arrangements, but not the exact arrangement. You get my point?
Yes.
Okay, very
Yes,
good.
please.
So this will be the first example. So if this one has, okay, more or less provoked your understanding, then let's look at, okay, our main word examples. Okay, so in how many ways can the following letters or digits be arranged, taking I 3 at a time, I 4 at a time? Okay, so quickly, let's go and have a look at what the solution. But before we look at the solution, any questions? Any questions? Okay, we thank God we are fine. So solution, that's the first thing that you write. Questions are numbered because your solution has been numbered. So question number 1, major question number. Okay, now is there anything that we need to underline? Okay, not really. So what I'm going to do is I will take A, then do it for I and I. Take B, do it for I and I. Somebody can take I, do it for all of them, then come and take I, do it for all of them. But my approach is going to be I take A, do it for I and I. Is that clear?
Yes, please.
Okay, so A. Okay, what are we giving? Okay, we are giving, okay, the letters of the word. Okay, so we are looking at method. Okay, so the letters that we have here. Now, first of all, let's ask ourselves, do we have distinct objects or letters in this case? Do we?
Yes.
Okay,
Yes,
good. So it
please.
means we know what we are going to do. So I. Okay, we are looking at taking what at a time? So taking 3 at a time. So we know, okay, I, this implies that, okay, R is equal to what? 3, am I right? As we move on now, you know, this is the first example. So the solution, don't take it hook, line, and sinker. I refine it going forward. This is the basic one. Okay, so in this case too, we know our N, okay, will be equal to, we count 1, 2, 3, 4, 5, 6, so 6. Okay, as we move on, like I said, the next one, that's where you have to be very particular about the presentation. So now we are looking for in how many ways. So we are looking for the number of ways. So in this case, I can write but number of ways. Okay, will be equal to, we know we are dealing with what? Arrangement. So arrange. So what do we do? It will be 6. Okay, arranging how many of them? 3. So 6 permutation was 3. So in this case, we know how to deal with this one. By definition, this will give us 6 factorial over 6 minus 3 factorial. Okay, so the next step comes down. So you can see that here, I'm not writing more than an equal to on the same line. So this gives us what? 6 factorial over 6 minus 3 is 3, so 3 factorial. And we know how to simplify this. So don't use your calculator. This will give us 6 times 5 times 3, sorry, times 4 times 3 factorial over, okay, 3 factorial. Remember where we are coming from. So this in effect will give us, this will cancel. So you get 6 times 5, which is 30. 30 times 4 will give us 120.
Yes.
Okay, so 120. So you've not drawn our conclusion. So you write therefore, okay, 120, okay, is equal to number of ways. Okay, going forward, the next one, like I said, the solution will be better. Okay, any questions before we move on to the second question? The B. Okay, we are fine. So we thank God, right? Okay, Prof. Ella.
So first of all, you didn't give your formula.
Okay, the formula is given. Only that is given in terms of, okay, values. Once I mature, I know my N. I know my R, so I substitute straight away. You get it?
Yeah. And another question. Can there be a situation where you get like same double digits, like
You mean duplicates?
Yeah, duplicates.
Okay, at this point, okay, I will not allow you to take the wind out of my sail. We'll get there. Okay.
Oh, okay.
So I've broken it down into different sets of questions. So we'll get there where you have duplicates or identical objects.
Okay, thank you.
Okay, you are welcome, my prof. All right, okay, so now B. Okay, so no, we've done it for I, so we are going to look at II. Is that clear? Okay, so II, before we go to the B. II, taking 4 at a time, so our R is equal to what? 4. You agree?
Yes, please.
Okay, so this time around, that's what I'm going to do. Instead of writing, okay, I'll just write therefore straight away, number of ways. Okay, because I can see that my conclusion is lengthy. Whatever I write here is what, so number of ways. Okay, will be equal to, we know, we are looking at what this time, right, to be 6 permutation 4. You agree? So which will be equal to 6 factorial over, okay, 6 minus 4 factorial. Okay, so that gives us what? 6 factorial over 2 factorial, which in effect will give us 6 times 5 times 4 times 3 times 2 factorial all over, okay, 2 factorial. Okay, so in effect, this will cancel that. So I'm waiting for you to do 6 times 5. So it will be 120 times what? Times 2, which will give us what? 240. Do you agree?
No.
Do you agree?
No.
No.
Then times 3. You get it?
Yeah.
Very good. Okay, so please, it's supposed to be times 3. So it will be 120 rather times 3. This and this will cancel. Is that clear? So that will give us what?
360.
360. Very good. So it means you are following 360 degrees. So here you can see that our conclusion is embedded in our step. So you've done the conclusion already. All correct.
Yeah.
Yeah.
Okay, so we are going to do one more. So between B and C, choose one. Hello, I'm waiting. C. All right. Okay, so now let's move on. So to C, if you had chosen B, you would have been a suspect. But if you chose was C. So let's go. So C, what are we giving? We are looking at, so look at the way we are going to deal with this one. So with this one, we are giving, okay, let's extract chemistry. Okay, so chemistry. So chemistry. Okay, so first of all, I. Okay, now I'm matured. So what am I looking at? I'm looking at taking, okay, 3 at a time. So straight away, I have that in mind. So as a rough work, I'll write R is equal to 3. Okay, so now let me come and get my N. N is equal to what?
9.
9. So first of all, check whether all your objects are distinct. All your letters are distinct. And obviously they are. So we have what? 9 distinct objects. And we are taking, okay, 3 at a time. So our R is what? Also 3. So therefore, number of ways. We know it will be N permutation R. But our N we know is what? Is 9. So then permutation, our R is what? Is 3. So this will be equal to 9 factorial over 9 minus what? 3 factorial. Okay, so which in effect will give us what? 9 factorial over 6 factorial. So in effect, we are going to get, 9 factorial can contain 6 factorial. So write this one as 9 times 8 times 7 and times 6 factorial all over 6, okay, factorial. So this will cancel that. So you do 9 times 8 times 7. I'm waiting for the answer.
504.
5
0,
0, 4. Okay, so you have 504 ways. Is that clear?
Yes, please.
Okay, as simple as that. So I believe with this, we should be able to do the I. Okay, let's quickly do that one because this is our last question. So that those who are still behind. Okay, Prof. Amma.
Mr. Ackman, please, the N and R, is it jota working?
Yeah, it's a rough work. I said now we are matured. Okay, you can see that this time around, okay, you know permutation, you need your N and you need your R. Okay, so you go and look for it. Okay, so in this case, again, therefore, so with this one, you know your N will be intact, but it's your R that is changing now. Your R is 4. Okay, even as you mature, you can choose not to write this. You will know that your R is now 3 and your N is what, and use this straight away. It's not necessary. You get it? You should be able to pick these values. So therefore, number of ways. Okay, will be equal. This time around, it will be 9 permutation 4. Okay, which in effect will be equal to, okay, 9 factorial over 9 minus 4, okay, all factorial. So if you continue, we are going to get 9 factorial over 5 factorial. Okay, we know how to simplify this. So that gives us what? 9 times 8 times 7 times what? 6 times 5 factorial all over, okay, 5 factorial. So I'm waiting for your answer. So it will be this 1 times 5, 504 times 5.
Please times 6 rather.
Times 6, forgive me, times 6.
3024.
3024.
Yes, please.
Okay, ways. All correct.
So if we don't add the ways at the end, that
Oh,
means
there is
it's
no,
wrong.
we won't penalize you. Only that usually, okay, if you ask you, well, how old are you? Okay, usually you won't say 70, you attach the units basically. Or number of ways, if you say 3024, we know you are looking for the number of ways. Okay, just polite to others. Therefore, there are 3024 ways. But if you don't add it, okay, it will not be costly at all. All correct.
Okay, sir. Yes,
All
sir.
right.
Thank you.
You're welcome. Okay, so now the first set's gone. Okay, we are going to look at one more, which is the E. Okay, but basically it will be the same. So E, what are we giving? So we've done these were letters. We are going to look at digits. It works the same way. Okay, digits will be treated as objects. Okay, and your letters equally will be treated as objects. So basically the same concept that we are going to look at. So E, what are we giving? We are giving, this time around, we are dealing with digits. And that will be 2, 4, 3, 5, 4, 8. Okay, so we come to I. Okay, therefore, number of ways, we are matured, number of ways. Okay, will be equal to, so we need to pick our N. But let's check whether we have distinct, okay, objects. 1, 2, 3, 4. They are all distinct. So our N is what? 4. Sorry, 5, forgive me. 5. Permutation. Okay, let's count. In I, what is our R? We are taking how many? 3, is that not it? So permutation 3, all correct.
Yes.
Okay, so as simple as that. So the rest will be, so it's the same way. So that will give us, we use the definition 5 factorial over 5 minus 3 all factorial, which in effect will be equal to 5 factorial over 2 factorial. So I guess from here you can carry on. Okay, so I'm going to assume this is my next page. So in this case, we are going to get equal to, then we'll get 5 times 4 times 3 and times 2 factorial all over 2 factorial. Okay, so this cancels that. So it will be 5 times 4, 20. 20 times 3 will give us what? 60. Am I right?
Yes.
Okay, so 60 ways. That's all. It's not far. So whether you are
Yes,
dealing with
please.
digits or letters, okay, it's the same concept. First, check whether they are distinct. If they are distinct, then we go the usual way. If you are taking part of them, then you use your usual permutation and interpretation. That is N permutation R. Okay, so now let's look at the next concept. Not the next concept per se, but our next question. Okay, this time around we are dealing with what? People. Okay, so not people will be treated as objects anyway, but we are actually not objects. Okay, so Matiti, Prof. Matiti, are you there?
Can you please go back?
Okay, all right. I guess you want to capture.
Yes.
Okay, all right. So let me know when you are done.
Please, I'm done.
Okay, great. So now let's look at the second one. In how many ways can 15 people be seated on a bench when only the following number of seats are available? So you can see that here, obviously there is no way, even if I give you 2 people, whether they are Siamese, they are whatever, there is no way 2 people will be the same. You agree?
Yes, please.
Okay, so they will be different in one way or the other. Okay, so now it means we are looking at arrangement of distinct objects, but we have 15 distinct objects. Okay, 15 people. And we know a bench usually is a bench circular.
No, please.
Okay, a bench is
Linear.
linear. Okay, so like I said, okay, if you prove further directly or indirectly, you will know that you are dealing with linear, but I've told you what we are dealing with is linear. Okay, when we get to, I think now they don't usually ask questions on circular permutation, but if time allows, we'll look at that one maybe briefly, but my concentration will be on the linear one, so please take note. So again, arranging 15 people linearly, okay, where you are supposed to, okay, we said the following number of seats are available. So if 2 seats are available, then it means at any particular point in time, if you are arranging, you should arrange only 2 out of the 15, true or false?
Sir, please come again.
I said, okay, you have 15 people, and here is the case, you have a bench, okay, which can take only 2 people at a time. I'm looking at A. So let's go and look at the solution. I'll, okay, throw more light on whatever that I was saying pretty soon. So let's look at the solution. Okay, so as you read question, okay, we check whether there is any salient part for us to underline. Okay, so not really. So now we go and write 2. Okay, and 2, we have a general information. So given, okay, how many people? 15 people. So it means you need to, this information is telling us what our N. So N indirectly is equal to 15. You agree?
Yes.
Okay, now we come to A. We are looking for the number of ways. And from A, if 2 seats are available, so like I was saying, I have 15 people. But 15 people, because 2 seats are available, I can only pick 2 at a time and arrange. You get the point? I cannot go beyond 2. Is my point well made? So any point in time that I'm going to, okay, make them occupy the seat, which can take only 2 people, you know that I will have only 2 people. So if I take the first person and the second person, you know each 2 that you take, you have 2 ways of arrangement. Okay, so this one, all that you need to know that we are looking at N people arranging 2 of them. So in this case, our R will be equal to 2. Okay, Prof. Ella.
Please, you said in permutations, they use words like arrange and arrangement, but over here I didn't see any. So how would I be able to tell
Very good question. I was going to ask at the end, but if you have asked, that's okay. Very good question. Okay, so you see, I said, yeah, that's why you said usually. Is that not it? Did I say always? No. Okay, so usually, so if you want to make your work very easy for you, then the keywords, okay, let you have it. But immediately the keywords are missing, you are supposed to study the question and look at the scenario and see whether you are dealing with selection or arrangement. Because whenever people are being seated, you don't select them, you arrange them, true or false.
True.
After your selection, you don't end there, you have to arrange them, basically. And in the same way, when you are, we come to combination anyway, but let me say this, maybe just to buttress my point. When you are answering questions, do you select questions and arrange or just select the questions? When you are answering questions, is your arrangement important? That's my question. When you are answering questions.
No.
When you are answering questions, it doesn't really matter the order that you answer your questions. We are only interested that maybe if you are supposed to answer 7 questions out of 9. Okay, we are only interested in you answering 7 questions. The order we don't mind. You get the point? So anytime you are dealing with answering questions, if you don't see the keyword select there, you should know that when you are answering questions, you just select questions, you don't arrange them. The order doesn't really matter. So you should equally know that you are dealing with combination, not arrangement, which is for permutation. I don't know whether you get my drift. Do you get my point? My professors, are you there? So here, the point that I'm trying to make is, okay, if the keywords are missing, okay, don't say that you are deficient. You are not deficient. Okay, we've not given you the short end of the stick. What you are supposed to do is probe further and look at the scenario, whether it suits permutation or that of combination. But we know that, and we just agreed that this one, we are looking at arrangement, though we don't see the keywords there. Okay, as simple as that. So in this case, like I was saying, AI, okay, so it's just A, forgive me. This time around, okay, it wasn't labeled like the other one. So it's just A. A, we are looking at what? We said how many seats are available. So because 2 seats are available at every point in time, out of the n people, how many will you select and arrange? Is it not 2? So the question will be 15, taking 2 at a time. Is that clear?
Yes.
Okay, so that will give us, therefore, number of ways. Oops. Will be equal to 15, okay, permutation, okay, 2. So this will be equal to, it's going to give us a huge number. So you can see that's I move from one line to the next line, right close to the margin. So that will give us 15 factorial over what? 15 minus 2 factorial. Okay, which in effect will give us 15, okay, factorial over, okay, 15 minus 2, which is what? 12 what? Factorial. Not huge per se. So we can deal with this one. So this gives us what? 15 times 14. Okay, times. Oh, 13, forgive me. Okay, all right. What is happening? I've started exhibiting symptoms early. Okay, all right. So this gives us what? 13 factorial over 13 factorial. So in this case, what are we going? This will cancel that, and we are going to get 15 times 14, which will give us
210.
Okay, so 210, okay, ways. All correct. Okay, do we need to do one more, or the understanding is there? It's the same thing like the objects, where you know the individual objects, okay, and they are distinct. But here, you know you are dealing with 15 people. So each of them will be treated as what? An object. Each person is treated as what? As an object. Okay, therefore you have 15 of them being what? 15 objects. So your n is 15 and you need to know your r. So with this one, your r will be 4. Okay, your r will be 5. Okay, so which will give us 15 permutation for 15 permutation 5, 15 permutation 7, and 15 permutation 9. Okay, you know how to simplify that using the definition. Okay, Prof. Ama.
So say, please, you're going to say that when two benches are available,
When
15
two,
benches.
no, it's only one bench, but that bench can seat, okay, 2 people.
Okay.
You get the point?
Yes, please.
It's
Yes,
only
yes.
one bench, but that bench, only 2 people can what? Okay, can be seated on that bench.
Oh, okay.
You get it now?
Yes, please.
Okay, all right. So that's why you can see, even it's qualified on a bench, so only one bench, but that it can take 2 people. All right, so in this case, it means that bench can take 4 people. Okay, when the bench can take 5 people, okay, how do you deal with it? That will give us exactly what we've done. Okay, so at this point, okay, this will take us to our next, okay, concept. Okay, that will be B. So B, look at what we are going to look at. But before we come to the B, any questions? Okay, so we are going to look at another special situation. Okay, so here we are looking at the number of arranging n distinct objects, taking n at a time. N distinct objects, taking n at a time. So invariably, this means you have n objects and you are arranging all of them at a time. Do you agree?
Yes, please.
Because our R is equal to n. Okay, our R is equal to n. Let me quickly do something. It seems what I have there is an issue with it. So let me quickly effect that change here. Okay, so that will give us n permutation n, not R. Other than that, what you have there, you wouldn't be able to relate with it exactly. I guess you get my point. Okay, so
Yes, please.
now n permutation R, but your R is n, taking n at a time. And we know by definition, this will give us n. But remember, we did this. Do you remember when we were doing the simplification? We did this, which gave us n factorial over 0 factorial, which gave us n factorial. Okay, all right. So anytime you are given objects, okay, and you are asked to arrange all of them, okay, take note. In this case, the key word that you need to look out for is check whether the objects are distinct. So I'm talking about distinct objects. If I have n distinct objects and I'm arranging all of them, the number of ways will always be my number of objects factorial. If I'm arranging all of them, take note of this. Okay, so here, let's look at an illustrative example. In how many ways can the letters S, E, A be arranged? So here, did the question tell us, okay, the number that we are supposed to select and arrange? The number that we are supposed to take and arrange?
No, please.
No. So when the question is silent on the number that you are supposed to take and arrange, which is your R, okay, it means the arrangement should be done for all the objects that you have there at a go, with no bias. So with this question, okay, here you can see that your number of objects that you are taking, you could be given, or we can be silent on that. If we are silent on that, then it means the arrangement is for all objects. If the arrangement is for, okay, a certain number of objects, then that one specifically we are supposed to tell you. We cannot be silent on that. Is that clear? So where you are arranging all of them, we can choose to tell you or not to tell you. But where you are arranging parts, you are taking parts of them and arrange. We have no option than to tell you that you are taking this number, okay, to arrange out of the total number of objects. All correct?
Yes, sir.
Okay, so here, as usual, so a solution to the illustrative example, given SEA. This time around, you are arranging all of them. So number of ways will be equal to, n factorial. And what is our n? N is 3. So it will give us 3 factorial is equal to what? 6. Is that clear? So now let's look at our first set of work examples. First set of work examples. So this one, as usual, it will just be a calculator work. Okay, Prof. Adoma.
Mr. Ackman, please can you move to the previous slide?
Okay, what happened to your voice?
Please, I'm not feeling well.
You know you are not supposed to say that. Learn to be positive. You are recovering or you have recovered.
Amen.
All right.
Please, I'm done.
Okay, all right. So I don't know whether it's my prayer that God is answering. Today, I know I'm free. Now I am fully convinced I'm free. Okay, from Prof. Adoma. Okay, so let's move on. So again, in how many ways can the letters, digits of the following words or numbers be arranged? Okay, so the same concept that we used. Okay, only that now we are going to look at whether we are taking part of them or we are arranging, all of them. So solution to question, the major question number is 1. Okay, so now let's go and take A, the first minor. What are we giving? You can choose to write given, or this time I will just write method. Okay, so first of all, let's check whether our objects are distinct. Are they distinct? Again, we've done that, so we've answered this question if they are distinct. Now let's see. Okay, in this case, I know that my n is equal to, okay, your n is what? Is it 6? So your number of distinct objects is equal to 6. Now we know we are looking at what? Again, let's see whether we can get the keyword there. Yes, arrange. So we are looking at permutation. So it will always be, okay, something permutation, something. So we know our n, but the r, okay, is not given. So let's see. Okay, the r is not given. So when the r is not stated or is not given, what does that mean? What does that imply? When the number that we are taking to arrange is not stated, what does that imply? Okay, Prof. Natalie.
It implies that the n is equal to r.
N is equal to r, so meaning we are arranging all of them. Anytime you take,
Yes.
you have to arrange 7. So we are looking at, okay, possible arrangement with 6 words objects at a go. So in this case, we are going to get, therefore, straight away, number of ways. Okay, will be equal to, somebody who doesn't know that's, okay, n permutation n is equal to n factorial. The person will write, okay, 6 permutation 6, okay, and end up getting the 6 factorial. But we know that this will give us straight away 6 what? Our n factorial, and n is 6. So you use your calculator to find this, then you write it there. All correct.
Yes, sir.
Okay, so I'm waiting for your calculator value for 6 factorial.
$720.
Okay, 720. Okay, obviously, so ways. Safa.
Yes, please.
Okay, so if you are not matured, you write maybe n permutation, so 6 permutation 6 before. But I know anytime you are asked to arrange and you are arranging all of them, it will always be your normal factorial. Take note. So I'm going to do one more, okay, for the letters. Then I'll go and take one for the digits. So in this case, again, the second one, which one? This time around, I will go for Richmond. Okay, so Richmond. That's what we are giving. Oops. Okay, so Richmond. Okay, so here, how many distinct objects do we have? As a rough work, n is equal to?
8.
Did you say 8?
Yes, please.
Okay, so do you agree that n is equal to 8? Okay, so therefore, number of ways. Okay, will be equal to, remember, we are arranging all of them because R will also be equal to what? 8. We are not told. So in this case, we are going to get 8 what? Factorial. Okay, whatever that your calculator gives you, you write it there and you attach ways. Point well made.
Yes, sir.
Okay, so 8 factorial gives us
40,320.
okay, so 40,320.
Yes.
320.
Yes, please.
Okay, all right, ways. So please, okay, take note. So with that, I think E becomes trivial. So let's pick one of the digits question. So it's the same concept. They will be treated as objects. So in this case, therefore, number of ways. Oh, sorry, I didn't extract the object that I'm arranging. Very important. Okay, so please let's go for it. And we are looking at 2, 4, 3, 5, 8. Okay, so therefore, number of ways will be equal to, let's count, 1, 2, 3, 4, 5. Distinct, okay, 5 distinct objects. And we are arranging all of them at a time. So that will give us 5 factorial, which will be equal to whatever that your calculator gives you, you attach what ways. Okay, so 5 factorial will give us
120.
120. So you have 120 ways. As simple as that. All correct.
Yes, sir.
Okay, so we are going to move on to our second, okay, work the example. Okay, so this one to the other one, let me see whether I can. Okay, all right, so let's look at this. In how many ways can the following number, okay, number of different books, okay, be arranged on a shelf? Or should I be the following different books be arranged on a shelf? Let me quickly do that before, do the editing, okay, before. So in how many ways can the following, okay, all right, so can the following different books, okay, be arranged on a shelf, okay. All right, we have to indicate that the books are distinct, so that information must be there. All right, so now in how many ways can the following different books be arranged on a shelf? So again, you know that usually shelves are linear. You arrange books linearly. True or false?
True.
Okay, so indirectly, the question has given you that information that you are talking about linear arrangement. And again, we are looking at different books, distinct books. So we don't have any duplicate book, don't have any identical book. Okay, so it's the same concept. Okay, let's look at 4. Hey, did I give you? Okay, yes, we have 4 books. So it means if you have 4 different books and you are arranging and you are not told the number that you are supposed to arrange, take and arrange, then we are looking at what? Okay, 4 permutation, 4 the same as 4 factorial. True or false? Okay, so
True.
question 2. Okay, you are following very well. Keep it up. So in this case, I don't have any information up here. So I come to A. Okay, what am I giving? 4 different books. So giving, okay, 4, okay, different books. Okay, so I know my n is equal to 4. So I know, therefore, number of ways, they are different. So, okay, you should know will be equal to n factorial, but your n is 4, so that will give you 4 factorial. Your answer, you write it there. So this will also give us 6 factorial, 7 factorial, 9 factorial. Is that clear?
Yes.
Okay, so 4 factorial will be 4 times 3, which is what? 12. Okay, then 12 times what? 2, which is what, 24. So you are going to get 24 ways. All correct?
Yes.
Okay, so I guess the B and C and D, you can do it. So can I move on? Okay,
No, C.
okay, so we should do C.
Yes, please.
Oh, it will basically be the same thing. The rest will be calculator work. I think C, haven't we done, okay, C, it will be giving 7 different books. Is that okay? So C, giving, okay, 7 different books. So it means your N is equal to what? And the person who said no, your N is equal to 7. So that will give us, you are arranging all of them. So it will give us 7 factorial. Okay, and you use your calculator, whatever that you get, you write, okay, the value there then moves. And 7 factorial gives us
5040.
okay, so 50, okay, 40. Okay, ways. As simple as that. So far. Okay, so we thank God. Okay, so this takes us to this question, and this will be, okay, another question which follows. Let's see, so in how many different ways? Okay, so sorry, how many different ways are there for the following number of people to stand in a line? So obviously you are looking at what? A linear, okay, arrangement to buy a football ticket. So you can see that here, obviously, can you see the keyword? Let's go back to the other one. You can see that the keyword was there, arrange. But in this one, okay, do you see the keywords there, any of them? Obviously, no. Is that not it?
Yes.
So, but again, you look at the scenario. Okay, usually when we are going to buy a ticket, okay, and we stand in a line, you know, obviously we are talking of arrangement. That's the more reason why if somebody moves from the back, okay, and the person comes to be in front of you, you are not happy. So it's the same number of people that you have there, but the order really matters. You get the point?
Yes, sir.
So you don't jump the queue, you wait for your turn. So basically it's the same. So I will do one more for this, only that again, you are dealing with people. So each of them will be considered as an object. So if you have 5, okay, people, then it means you have 5 objects. In that case, your N will be 5. So it's basically the same thing. Okay, this question is introduced for you to know that you can deal with, okay, people as well. Okay, you can deal with books, not only digits and words and letters. Okay, so A, what are we giving? We are giving, don't write different people. Okay, obviously we are giving 5 people. Okay, and they will be different. So in this case, therefore, by number of ways, you know it will be n factorial, but your n is 5. So it will be 5 factorial. And we've done 5 factorial already. So whatever that you have there, you write what ways. Afa. So what did we get for 5 factorial? Hello, my professors. What did we get for 5 factorial?
360.
360, you said?
120 ways.
How can 5 factorial be 360? Okay, so let me, the person who said that cannot be trusted. Okay, so 120. Just use your calculator. This calculator work, you shouldn't, okay, get it wrong. Okay, so at this point, okay, we are done for the first. So we are going to look at our next concept. Okay, that will take us into the solution and the answer to the question that, okay, the person who wanted to take the wind out of my sail, okay, asked. Okay, so at this point, okay, you've done 1 hour. Let me give you your water break. We'll come back and continue. Okay, so welcome back, okay, from the water break. Now we are going to where it is a little technical, but it's not difficult. Once you get the concept, even questions that might not even apply require the use of this, okay, you would want to use it. Okay, but that's not to say you shouldn't think through the question, but I'm trying to say that you find it interesting whenever, okay, your understanding is up there, you understand. So this is it. Okay, so now we are going to look at a situation, okay, permutation with identical or duplicate what objects. Permutation with identical or duplicate what objects. So you realize that the first two, the A and B, we're dealing with distinct objects where you are taking part of them to arrange. Okay, and the B was you are arranging all of them. You are taking all of them at a time to arrange. Okay, so all we are dealing with distinct. Now we have duplicates, at least one duplicate or identical what objects. Okay, whenever you have that situation, what do we do? Okay, so this is the formula that we are going to use. Number of ways will be equal to n factorial. I will explain, don't worry. You've seen n, you've seen r, you've seen sub, whatever, all these, you've seen them before. So don't let it confuse you. I will break it down for you to understand. It's not difficult. Believe me, you. So number of ways is equal to, or will be equal to n factorial over r sub 1 factorial times r sub 2 factorial times ellipses up to r sub k factorial. And by that, this is what I mean. Okay, so this is the definition of the parameters that you have here, where n will be your total number of objects, your total number of objects. Then r sub 1 will be equal to your first identical or alike objects. Okay, we'll come to specifics, so don't worry, I'm only explaining, you get it. R sub 2 will be your second alike or identical objects. And R sub k will be your k, okay, alike or identical what objects. So this is it. Okay, this formula that you have here, in actual fact, is the formula for arrangement of objects taking all at a time. Arrangement of objects taking all at a time. However, the formula that we quoted, which gave us only the numerator n factorial, for the situation where you are dealing with distinct objects, different objects is embedded in this. So if you know how to deal with duplicates, okay, or identical object arrangement or permutation, you should know how to deal with what than duplicate or distinct what object arrangement. By that, this is what I simply mean. Okay, very soon I think I'll go back, but let me come to this straight away. So let's look at the illustrative example. In how many ways can the letters of the letters S, E, E be arranged? So if you look at the letters that you have here, do you see duplicates? Do you see identical objects? Or all the objects are distinct? Do you see identical objects, my professors?
Yes, please, identical
Yes.
object.
Yes, you see E and E. You see duplicate what objects. Okay, so as usual, solution given. Okay, your letters, you state them or you write them. Number of ways will be equal. So let's go and count our n. We said n will be the total number of objects, and the number of objects will be 1, 2, 3. So you have 3. So 3 factorial. Over with this one, you have only one duplicate object, which will be E. So we have only R sub 1. Only one, okay, duplicate what object. So R sub 1. And R sub 1, you have 2 E's. Okay, so your duplicate object, you have E, 2 of them. So that will give us 2 factorial. In actual fact, okay, please take note. Okay, when you were given SEE, now let me use SEA. When you were given this, we said where you are arranging all of them, we said the number of ways will be equal to what? N factorial. Do you agree? Which gave us the 3 factorial. Am I right?
Yes, sir.
Okay, in actual fact, it's supposed to be over each, okay, of the object what? Factorial. So S, I have one of them, 1 factorial. Okay, E, I have one of them, so 1 times 1 factorial. A, I have one of them times 1 factorial. Okay, however, I know that 1 factorial, 1 factorial, 1 factorial, my denominator will be 1, so it will not affect my numerator. Do you get the point?
Yes.
Okay,
Yes, sir.
so which will give you overall your 3 factorial. So that's why I was saying that even if you have what non-identical, or let me put it, non-duplicate what objects, and you were dealing with what do you call it, distinct objects, you can use the same formula, only that your denominator will be 1. So usually we don't consider. However, if you have duplicates, your denominator will never be 1. So anytime you are arranging and you have duplicates, okay, your numerator will take your n factorial, which will be the same as the arrangement with no duplicates or arrangement of distinct objects. But immediately you see a duplicate, then denominator will come in. And the denominator will be looking at the objects, the number of them. So if I have A, I have 3 of them, then it will be 3 factorial. If I have C, 2 of them, then times 2 factorial. So all my duplicates, okay, will be catered for in the denominator. Is my point well made, or I should come again?
Sir, please come again.
Okay, so I will come again, okay, using the example that we have here. All right. Maybe in our next meeting, I'll use another direction to explain. If the example that I will give you assignment, you don't do well, I will see if I can use another, okay, direction to explain. Okay, Prof. Matiti.
Mr. Can you please go back?
Okay. A question or you want to capture?
Please, I want to capture.
Okay, all right. So please, those of you who want to capture, okay, please, okay, make sure you, okay, all right. So this is what we have. Okay, so let's look at this question. I think we can get it from the solution. So let me look at what the solution is like. In how many ways can the letters or digits of the following words or numbers be arranged? So again, we are talking of arrangement. So quickly, let's look at this. It's not difficult at all, you get it. So let's look at, okay, this the only example that I will look at, the way it's not 1, 2. So I don't have any major question number. So it's likely this will be the only question. If it's not, then we'll move on to the next one. So what do we have? Okay, so A. Okay, so what are we giving? We are giving, okay, the word, okay, bell. So bell, we know the letters that it contains. So B, E, L, L. So bell. Okay, so now this is what we are going to do. Okay, you know there's the first example, so I might not present it the matured way. So I'm going to write number of ways. Okay, sorry, off. Let me put the off here. Will be equal to. Okay, so now we are going to deal with it as if, okay, we don't have what duplicate objects. So we count 1, 2, 3, 4. So we are going to get 4 factorial. All correct?
Yes, sir.
However, obviously we have duplicates, and we have how many? We have 2Ls. So it means divided by 2 factorial. All correct?
Yes, please.
Okay, so in effect, okay, our algebra all the way. So that will give us 4 also times what? 3 times 2 factorial all over 2 factorial, which will be equal to 12 ways. Afa?
Yes, sir.
Okay, all right. So you can see that obviously this formula works. Assuming maybe we didn't know the formula, you want to go by our crude way. Let me go back a little. So if we're looking at SEE, if you want to arrange this, so let's look at our usual, we are SEE is one arrangement of them. Am I right? One possible arrangement. Okay, we can also have ESE as a possible arrangement. Do you agree?
Yes.
We can have E, okay, ES. Do you agree?
Yes.
Any other possible arrangement that we can think of that has not been catered for?
No, please.
No, so you can see that how many do we have here per our good way? This will give us what? 3. Assuming you were given about 10 digits, did I say, or letters? Okay, obviously you can see the volume of work that you do before you can get your count and get asked what the number of ways. So that's where the formula will be important. So with this one, if you had gone by your usual approach, assuming you didn't know the formula and you didn't, so you will go for the, what do you call the distinct one. So that will give you 3 factorial. Or you can see that 3 factorial will rather give you 6, which is not what's 3. So obviously this should tell you that there should be a denominator. And the denominator will be the duplicate objects here, the number of them, okay, factorial. It's my point well made now. We are going to do more, so don't worry. Okay, you understand? And I haven't drawn my conclusion. So maybe I'll write there for here. We are mature. So then we go on to B. Okay, B, what are we dealing with? Giving equally. Okay, so equally. Okay, so in this case, therefore, number of ways we are matured. Okay, will be equal to, so this one, indirectly, I was trying to say that my R sub 1 was equal to 2. Okay, that's it. Remember, I use R sub 1, R sub 2. So this one too, if I look at it, when you matured, my R sub 1 in the formula will be equal to, I have only, okay, 2 of the letters being duplicated. So we have what? 2L, so that will be 2. Is that clear? Is my point well made?
Yes, sir.
Okay, so you know, usually it will be n factorial over your, so I know my n, 1, 2, 3, 4, 5, 6, 7. So I have 7 factorial. But that is not all. I have duplicates, so denominator will come in. So that will give me 2 factorial. So in effect, I'm going to get 7, okay, times 6, times 5, times 4, times 3, times 2 factorial, all over 2 factorial. All correct, my professors. So the answer, this cancels that. The answer, you write it here and you attach ways. So I'm waiting.
2,520.
2,500 and what?
20.
Okay, 2520. Is that it?
Yes, please.
Okay, great. So please take note of this, especially with the duplicates. Okay. Remember, if there is no duplicate, no denominator, and that's what, or with your numerator. Once you see duplicates, at least one of them, denominator will come in. So in actual fact, this should also be over b, which is 1 factorial, then times what? Your 1 factorial. But that will not affect the value of the denominator here, so you don't write it. Okay, so it's the same, okay, explanation. So on that note, we are going to look at what? The C. If you're able to do C, okay, then we do F. The rest of the question, you should be able to deal with it. Okay, so C. What are we giving? Okay, the word balloons. Okay, all right. So in this case, this is what we are going to do. Therefore, number of ways will be equal to, if you didn't know, again, I left out of, number of ways will be equal to, you know, okay, if you didn't have duplicates, we will count 1, 2, 3, 4, 5, 6, 7, 8. We are arranging all of them. So it will be 8 factorial. Is that not it? But I don't end there. I have to ask myself, do I see? Yes, I see about 2 duplicate objects. So that will give me over. Okay, so in this case, my R sub 1 will be, I'm taking the L, and that will be 2. So it's like 2 L's. Okay, then my R sub 2. This time around, I've gone beyond R sub 1. I have another letter duplicated, which is 0. Did I say 0? Oh, okay, so I have 2, okay, sorry, 2 O's. Is that clear?
Yes, sir.
Okay, so this time right, it will be 2 factorial and times 2 factorial in the denominator. So far.
Yes, sir.
Okay, so we'll do more, don't worry, if your understanding is not up there. So this gives us 8 factorial over, we know, okay, I think, okay, we could have expanded that straight away. Here, the 2 numbers in the denominator, remember when we were doing the, what do you call it, simplification, we said go for the bigger number, but unfortunately, all of them are the same. Okay, they have the same value. So we just write it up to what? Up to 2. Okay, for one of them. So 6. Okay, 5, 4. Okay, 3. Any of them will do 2 factorial all over. Okay, our 2 factorial then times 2 factorial here. That's not the one that I'll use to cancel, so I'll write a value. So this will cancel that. Okay, this will go here, maybe 2. Okay, then you multiply. So your answer, you attach weights. My professors, I hope you are following.
Yes, please.
Okay, so I'm waiting for your answer. 8 times 7 times 6 times 5 times 2 times 3. So it will be
Sir, please, 10,080.
10,080. So 1080.
No.
Oh, no, 10,080. So 2 zeros.
Yes, please.
Okay, all right, I'm coming. Okay, so 10 here. Is that clear now?
Yes.
Okay, so this is supposed to be your answer. So let's do that off what? Let me see whether we have another, okay, page. Okay, so I think this one will even be enough for it. So let's do the F. So we are dealing with the digit situation. What are we giving? We've been given the digits 8, 4, 3, 5, 8. Okay, so therefore, number of ways, you know we are arranging all of them. So whenever you are arranging all of them, it will always n factorial. So number of ways will be equal to n factorial, 1, 2, 3, 4, 5. So n is 5, so 5 factorial. But you ask yourself, do you have duplicates? And the answer is a big yes. Okay, you can see 2, okay, digits being the same. Okay, all right, so that gives us, so the denominator, it means there will obviously be a denominator, and that will be the 2 8s that you have there. So it will be 2 factorial, and you can continue from here. 5 times 4 times 3 times 2 factorial all over 2 factorial. Whatever that you get, you attach ways to it. All correct?
Sir,
Yes, please.
sir, please, I would like to ask a question.
Okay, go ahead.
And sir, please, if you have, if the numbers are more than 2, how will you solve it?
The numbers, which numbers?
Sir,
You are talking about your duplicates.
yes, sir.
Okay, so let me see whether the next, if I have a next question, that will cure that. Okay, if it doesn't, then this is what we are going to do. All right, so it is the same concept indirectly. What I said, let me go back to where I have space. Okay, so remember, assuming this is it, let me see if there is any, okay, I'm just assuming I have 2, 1, 2, 2, 8, 2, 5, what, 5, 7, 9, okay, maybe 2, okay, 1. Okay, this is what I've been asked to arrange this. Number of ways will be equal to. I hope you are listening.
Yes, sir.
You count, usually arranging all of them. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it will give you 11 factorial as your numerator. Obviously, there will be a denominator because you can see duplicates. Okay, so over, I have 1. How many of them do I have? So it's like, so I have 2 1s. Okay, sorry. Then which 2, how many of them do I have?
4.
4 2s. Is that not it? So it's like this is my R sub 1, this is my R sub 2. I hope you get my point.
Yes,
Yes,
sir.
please.
Okay, so any other duplicates? I can see 5.
Yes, please.
Okay, so 5. How many of them? Also 2. Is that not it?
2.
Okay, so sorry, 2 5s. Let me write it here, 2 5s. So ours are 3. So it means it will be over, okay, the one, I have 2 of them, so 2 factorial. Times, okay, the 2's, I have 4 of them, so 4 factorial. Then times the 5, how many of them? 2 factorial. You get it now? I've gone beyond the video.
Yes, sir.
You get it now? All right. So
Yes.
you should be able to deal with that. All right, okay. So if it's letters to basically the same way. So if it's well understood, then we are now I'm going to occupy you with your classwork. Okay, I want to be sure that this one is well understood. So we are going to end the class here. The next concept that we are going to look at will be conditional permutation, and that will be treated, okay, God willing, on Thursday, which is our next meeting. So I have to be sure that what I have done today, you really understand before I can touch this, because it will involve, okay, what we have done. All right, so I am going to end here. Okay, but before I finally bring the curtains down, any questions? Hello, any questions? Remember, if you do this as your rough work, okay, don't forget to strike it out. You know, I've told you this. So even if I fail to strike it out, you cannot, because you know. Is that clear? All right, so I'm waiting. Any questions? All right, so if you don't have any questions, then we are going to bring the curtains down here. So once again, thank you very much for your attention and for asking questions and making the class very interactive and successful. God bless us all.